So here's number 14, and we have a gas, we have originally occupying some volume, so that's like an initial volume, an initial pressure, an initial temperature, and then we have changed, so that means like a final volume and a final pressure. And they ask what's the new temperature, so that's like a final temperature. So this is going to be some sort of a gas law problem. And let's... Okay, so we're talking about gas laws, and these are the two formulas that you're going to be using in gas laws. This is, I think, called the ideal gas law, and P is pressure, V is volume, N is number of moles, R is the gas constant, and T is temperature in Kelvin. And the other law, which I think is called the combined gas law, though I don't really care what they're called, is the initial pressure times the initial volume over the initial temperature in Kelvin is equal to the final pressure times the final volume divided by the final temperature in Kelvin. So if we look at this, we can actually start cataloging what all these values are, and it'll sort of tell us, or hopefully it'll tell us, which of these two formulas we should be using. So there's V1 is equal to 0.925 ATM. Atmospheres is a unit of, atmospheres is a unit of pressure, right? So I'm totally messing this up. So volume is like liters and milliliters. So that's 10.1 liters. So 10, one more time. There we go, 10.1 liters. Pressure 1 is equal to that many ATM. And we have 25 degrees Celsius for the original temperature. And whenever I write down Celsius, it bugs me. So, so I am going to change it immediately, because I need to have these things in Kelvin to be able to use them, and there's always this potential for me to make a mistake if I don't convert to Kelvin. So converting from Celsius to Kelvin, what I do is... And you want the answer in Celsius? Yes. So to use these formulas, you have to do them in Kelvin. You do not have the option. And if you need to report the answer in Celsius, then you'll convert back into Celsius at the end. But in order to use these formulas, you absolutely have to convert it to Celsius, or sorry, to Kelvin. So you add 273.15 to convert from Celsius to Kelvin. So that's 298.15 Kelvin. 298.15. Man, there we go. Better handwriting. Degrees Kelvin. Okay, so we have more information to put down. There's just a lot in this problem. Our final volume is 14.2 liters, and our final pressure is 625 torr. Okay, so it's probably a good idea that when you do these problems, you should look at the answer choices first. I didn't. So I'm looking at these answer choices. They're all in degrees Celsius. So I'm looking at this, and I'm like, okay, I'm going to be solving for a final temperature. And it's pretty clear to me that I'm not going to be using this formula because they don't give us moles, but I'm going to be using this formula because they give us a lot of information here, and we're actually solving for a final temperature. So if I want to solve for this final temperature, what I'm going to do is I'm going to multiply both sides of this equation by T2. If you want to do it by cross multiplying, you can. So you'd multiply this thing times this, and this times this. So I don't see why I wouldn't do that. It's kind of a roundabout way to go at it, but why not? So here, like with cross multiplying, you're going to multiply the T1 times P2 V2, and T2 times P1 V1, and this is what you get. We want to solve for T2. right? That's what we're looking for is the final temperature. So T2 equals, I have to divide everything by P1 V1. So that's going to leave us with T2 on this side, and we're going to have this stuff divided by P1 V1. So this is our equation, T1 P2 V2 divided by P1 V1 equals T2. That's pretty cool. We're going to use this. And at this point, it's pretty much plug and play. Let's think about these units to make sure they make sense before I actually do the calculation. And you'll be doing this in your calculator. I do it in Excel. But T1 is in units of degrees Kelvin. P2 is in units of torr. V2 is in units of liters. And then P1 is in units of ATM, and V1 is in units of liters. So here's the problem I have, and you'll see this very quickly. Liters cancel, and I want to get just some sort of temperature that I can convert back to Celsius. So this would be fine if I just had Kelvin by itself. But look at torr and atmosphere. I need to convert one of these into the other. I'm going to convert torr into atmosphere. There are 760 torr in every atmosphere, so I can convert this. If I divide this by 760, I'll get this in atmospheres. So, yes, there are 760 torr in an atmosphere. There's also 760 millimeters of mercury in an atmosphere. They're the same unit. They mean the same thing. They're the same amount of pressure. So millimeters of mercury is a torr. 625 divided by, let's do that, equals 625 divided by 760. Okay. So we have that T1 P2 so I'm going to have T1 P2 V2. V2 is 14.2 liters, and I'm dividing everything by P1 V1, so I need P1 V1. P1 is 0.295 atmospheres, and V1 is 10.1 liters. Okay, so I'm... Yes, 0.822, that's the pressure in atmospheres. Okay. So we end up getting a temperature that's 372.7 roughly. This is the T2 that we were solving for. But we wanted to get this in Celsius because that's all of our answer choices are in Celsius. So we are going to have to subtract 273.15 from that. So we get 99 something. So that's from Kelvin to Celsius. So let's see if that's in the answer choices. 99.5. Yes, that's probably fine. D is probably right.
After all of those stuff, you just like multiply it, it's going to be like 209.
So let's make sure that this makes intuitive sense as well. So we took a volume and we expanded it. So typically when that happens, temperature drops. And we took a pressure and we reduced it. We went from like 0.925 to 0.822, whatever. So again, typically when that happens, temperature drops. So I wonder, does that make sense?
I thought if the volume increases, the heat increases.
Well, if you look at the formula, as if you have like an increasing, oh yeah, you're right. Okay, so if the volume increases, so does the temperature. Yeah, you're right. I was wrong about that. So you have two competing factors, and I don't know which one's going to overwhelm it, so I have to rely on the math. I don't have a good way of ruling out answers based on intuition. Sorry, so my intuition failed me on this one. So I have to go with the math and say that it's D. Let's make sure. And 14 is in fact D. So thankfully the math kind of worked. For these on the test, if you don't get the exact answer, you can actually go back. I think a lot of these are based on the idea, or the fallacy that you would use 273 as a conversion factor, sorry, a conversion difference between Kelvin and Celsius. So you might want to troubleshoot with that. Instead of doing 273.15, you might want to go back to 273. That would probably resolve this and make it so you would round to 99.